Hello students, in the previous video of Boolean logic, you learnt about logic gates, that is AND, OR, NOT and their truth table. You also learnt about the logical operations addition, multiplication and complement. Then you learnt how to draw a truth table for a given expression. In this video, you will learn the principle of duality, the basic theorems of Boolean algebra and their proof, then De Morgan's rule and its proof, and you will also learn how to find the complement of a given expression, right? So the principle of duality is applied to get or derive an equation from an existing equation. So when you are given an expression, a Boolean expression, by applying the duality principle, you can get another expression from that expression. Okay, so look at the second point. The principle states that starting with a Boolean relation, another Boolean relation can be done by doing what? There are three steps that you have to do to find the dual of a given expression. To derive a new expression, you have to change each OR sign to AND sign. Hope you remember OR sign is represented by plus. So in a given expression, change the plus sign to AND, which is dot. The second step, changing each AND to OR. So all the plus symbol should be changed to dot, all the dot symbols to be changed to plus. Then third step, replacing each 0 by 1 and each 1 by 0. If you do all these three things in a given expression, automatically you can derive a new expression. So this is called, the derived expression is called the dual of the original expression. So an example is also given. There is an expression stating 0 plus 0 equal to 0. This is an expression. So apply the principle of duality. According to the principle of duality, 0 should be changed to 1, 1 should be changed to 0, plus should be changed to dot and vice versa. So 0 changed to 1, plus changed to dot. 0 changed to 1, 0 changed to 1. So 0 plus 0 equal to 0 is an expression from which we have derived another expression which is called the dual of the original expression. This is the dual. The derived expression is called the dual of the original expression. See, there is another example. 1 plus 0 equal to 1. This is one expression. Now change this to 0, plus to dot, 0 to 1, 1 to 0. So we get the dual as 0 dot 1 equal to 0. Right? So this is how you apply the principle of duality. Now we will work out some examples and find out the duals of given expression. So we have some problems which we will solve now. So look at the first one. X dot x bar equal to 0 for each x. This is the given expression. Using this, you have to find the dual. So the expression states x dot x bar equal to 0. Now what does the rule say? X bar should not be changed. So retain x as x and dot should be changed as plus. X bar will be as such, equal to is as such, but 0 will be changed to 1. So this is the original expression. This is the dual of the given expression. Right? Now look at the second one. X plus 0 equal to x. So what is the principle of duality? Plus should be changed to dot, 0 to 1, 1 to 0. So x is same, plus to dot, 0 to 1, equal to is the same, x is the same. So the terms x, y, z, x bar, y bar, z bar should not be disturbed. So retain as such. Only the symbols and 0, 1 should change. In some expressions, there won't be 0, 1 at all. Look at this. X plus y bar. X plus y bar. What is the dual of this expression? X dot y bar. That's all. Look at this. Xy plus xy bar plus x bar y. What is the dual of this expression? Xy means x dot y. So this will be changed to x plus y. And this plus will be changed to dot. x dot y bar will be changed as x plus y bar, and plus will be changed as dot. X bar y is changed as x bar plus y. So this is the term. I'll put a bracket so that the expression does not change, right? So this is how you get a dual. Look at this. A plus A bar B plus B bar. So A is the same, plus will become dot. A bar B will become A bar plus B. Plus will change to dot. B bar will be as such, right? Now this one. X plus y bar plus z into x plus y. I'll write below this, it will be easy. X dot y bar dot z. Here supposed to be a dot, so plus x dot y. So all the plus to dot, dot to plus. So this is the dual of this expression. Now let's find the dual of this expression, x plus y. So this will become xy. Here there is a dot, so change it to plus. X bar plus z bar. So this will become x bar z bar. Plus will become dot. Y plus z will become y dot z. So this is how you find the dual of the given expression. So whatever expression is given, apply three things. Or convert all plus to dot, that is addition to multiplication. Multiplication symbol will be changed to addition. 0 to 1 and 1 to 0. Don't touch or disturb any variable. X bar, y bar, z, nothing should be done in that. Retain as such. You will get the dual of the given expression. Next, we will move on to the basic theorems of Boolean algebra. Now look at this. These are the 10 important laws which you have to remember. The properties of 0 and 1 are very simple. We have learnt this in the basic truth table. So whenever there is a value and 1 0, you will get a value in addition. If any one value is x, output will be x. But regarding multiplication, if 1 is 0, answer is 0. So 0 plus x is x, 0 dot x is 0. Property of 1 plus x is equal to 1. Whether it is x, 0 or 1, output will be 1. 1 multiplied by x will be x. Because if this is 0, answer will be 0. Then, idempotence law states that x plus x equal to x. X dot x equal to x. Involution law states that x complement of complement is x itself. It is like minus of minus, which is plus. So x double bar is x again. Law of complementarity. This is an important law. X plus x bar is equal to 1. An expression, a variable plus its complement is 1. A variable multiplied by its complement is 0. Right? Commutative law, associative law, you are very much familiar. So x plus y is y plus x, x dot y is y dot x. Associative law, x plus y plus z is x plus y plus z. Same thing applies for multiplication. Distributive law, again you are familiar, x into y plus z is xy plus xz. There is another expression which says x plus yz equal to x plus y plus into x plus z. You may be little bit confused with this, but we do have a proof for this. Then you will understand why this is so. Then absorption law. X plus xy is equal to x. X into x plus y is equal to x. And then there is another law called the third distributive law. X plus x bar y is equal to x plus y. So if you have a question saying that state and prove the commutative law or state and prove the law of complementarity using a truth table. Prove the absorption law using the truth table. First you have to remember all these laws. Then how to prove this law using a truth table. So in the previous video I already told you how to draw a truth table. So let us prove absorption law using the truth table, which says x plus xy is equal to x. So I'll show you. X plus xy is equal to x. This is absorption law. We are going to prove this using the truth table. So how do you draw a truth table? Check how many variables are there. There are two variables, x and y. So take them as the input. Because there are two inputs, you will have four input combinations. Then x is already there, x into y you have to find out. So when you do multiplication, 0 into 0 is 0, this is 0, this is 0, this is 1. So what is this expression? X plus xy. X is here, xy is here, add these two. So 0 plus 0, 0 plus 0, both are zeros. 1 plus 0 is 1, 1 plus 1 is 1. Okay, so the LHS is ready. What is RHS? Here. X is already here. This is LHS, this is RHS. Just check if both are same. Here RHS is 0, 0, 1, 1. LHS is also 0, 0, 1, 1, 1. Which means we have proved that x plus xy is equal to x. Right? The same way, x into x plus y is equal to x. So, write x, y here and give the input combinations 1, 0, 1, 1. Then find x plus y 1, 1, 1. Because any 1 is there, you will get a 1. Now, LHS is x into x plus y. So, x into this. So, 0 into 0, 0 into 1. Any 1, 0 is there, you will get a 0. 1 into 1, 1 into 1. So, 1, 1. So, this is the left hand side and this is the right hand side. So, both are equal, which proves that x into x plus y is equal to x. So, to prove the distributive law, x plus y z equal to x plus y into x plus z, you need three variables because it involves x, y, z. So, x, y, z, you have 8 input combinations. First, find y, z. Y into z is 0 into 0, 0, 0. Here 2 1s, so 1. Here there are 2 1s, so output is 1. Now, what is LHS? X plus yz, that is x plus yz. So, you will get 0, 0, 0, and wherever you have a 1, the answer will be a 1. So, this is LHS. Now, what about RHS? X plus y, here I have found out. X plus z, I have found out. What is RHS? X plus y into x plus z. So, this into this. So, 0, 0, 0. The remaining are all ones. So, you will get 5 ones. Now, check the left hand side and check the right hand side. Both are equal, which proves that x plus yz equal to x plus y into x plus z. So, first you have to remember all the laws, and whenever you asked a truth table, verify that using the truth table. It's very easy. Next, you will learn how to give the algebraic proof of the laws. Now, these are all very simple statements, so you need not give the algebraic proof for that. The truth table is more than enough. But when you want to algebraically prove the laws, you have 3 important laws for which you have to learn the proof. The first one being distributive law, next absorption law, and third is only for these 3 laws you have to learn the algebraic proof. So first I will tell you how to prove the distributive law. Now every law, if you observe, is the dual of the first law. Say x into y plus z. What is the dual? X plus y dot z. See, x plus y dot z equal to xy, x plus y. So the second expression is the second law is the dual of the first law, which means that if you algebraically prove any one of these, then it is automatically understood that the second one is also proved. So whenever you asked a question saying that give the algebraic proof of distributive law, you prove any one law and also write that because the second law is the dual of the first law, that is also proved. Okay, so I will show you how to prove the distributive law. So in the distributive law, the second one is very easy to prove. X plus yz equal to x plus y into x plus z. So we'll see how to arrive to the proof. X plus yz is equal to x plus y into x plus z. Now consider the right hand side and cross multiply. You have to do the normal cross multiplication. X dot x plus xy so x dot x dot z plus x dot y plus yz, right? So first I have cross multiplied the right hand side. Now if you observe this, this is one law. X dot x, according to idempotence law, x dot x is equal to x. So here you have to write, according to idempotence law, x dot x is equal to x. So this can be reduced to x. So write the remaining things as such. X plus, now here you have two z's, so I'm going to bring this xy to the front, this side, and the z terms I will put it in one side. Okay, in this, take this x commonly outside, x into 1 plus y, and retain the other things. Now what is 1 plus y? According to the property of 1, 1 plus y is 1. So 1 plus y will become 1. X dot x is x. So x plus xz plus yz. Now in this, take x outside commonly. Again you will get 1 plus z plus yz. This 1 plus z again, according to the property of 1, is 1. So this term will become 1. So x plus yz, which is equal to the left hand side. This is the proof of the distributive law. So we have proved the second law. So obviously first law is also proved, because one law is the dual of the other. Okay. Next we will see the proof of absorption law, the next law. So you have two laws in absorption law. X plus xy is equal to x. X into x plus y is equal to x. So the second one is very easy to prove. Why? Because you have a multiplication here. So you can just multiply and bring this x very easily. So I will take the second law and prove it very easily. X into x plus y is equal to x. This is the second law of absorption law. So multiply this term, x dot x plus xy. This is the LHS. I am multiplying the terms. Now again you will understand very easily. X dot x, according to idempotence law, is x. But every time you have to write how you are simplifying based on idempotence law. X dot x is equal to x. I am applying this rule. This is what you have to write. Next, so from this term you can understand what I am going to do next. Take x commonly outside. So 1 plus y according to the property of 1. 1 plus y is equal to 1. So which is x dot 1, which is x. So we have arrived at the RHS, right hand side. So hence it is proved that x into x plus y is equal to x. This is the proof of the absorption law. Next we'll move on to the proof of the third distributive law. The third distributive law states that x plus x bar y is equal to x plus y. Now consider the left hand side, x plus x bar y. Now if you observe this, there is no way to cross multiply or take anything commonly outside. There is no way to reduce this. So I am going to increase this term. This x can be written as x dot 1 so that the value doesn't change. According to the property of 1, 1 dot x is x, right? Next, this 1 can be written as 1 plus y. Right? Again the reverse method. Instead of reducing, I am first expanding. Right? Now cross multiply this. X into 1 plus y will become x into x plus y plus x bar y. Now here you have a common term. Right? So take that common term outside. X plus y is taken commonly and written as x plus x bar inside. Now this, according to the law of complementarity, x plus x bar is equal to 1. So x plus y. This is the right hand side. Hence the proof of the third distributive law. Now move on to an important theorem, which is the De Morgan's theorem. So we will state and also prove the De Morgan's theorem now. Okay. So there are two De Morgan's laws which states x plus y complement is equal to x bar dot y bar. x into y complement is x bar plus y bar. So De Morgan's law states that x plus y's complement is x bar dot y bar. Now we will give the algebraic proof of this. So how to prove this expression? De Morgan's law states that x plus y is a term and the complement of x plus y is x bar plus y bar. Now we already saw a law of complementarity, right? What did the law of complementarity state? X plus the complement of x is 1. X and multiplied by the complement is 0. So an expression and its complement added together should give 1. So x plus y's complement is x bar dot y bar. If you have to prove that this is the complement of this, you have to prove that x plus y added with its complement is 1. Then you should also prove that x plus y multiplied with its complement is 0. If you prove that, then obviously it is understood that this is proved. So how do you understand this? How do you start the proof of this? Let x plus y is equal to a term called p. This left hand side. X plus y is a term. So x plus y is equal to p. So what is p complement? It says complement of this expression p is x bar dot y bar. So according to the law of complementarity, you have to prove that p plus p bar is equal to 1. So let me write p x plus y plus p bar x bar y bar. You have to prove that this is equal to 1, right? Now, according to the distributive law, what does the distributive law state? X plus yz is equal to x plus y into x plus z, right? So consider this term as x and this term as yz, x plus yz. X plus y plus z is equal to x plus y, x plus y, right? Into x plus z, x plus z. It is of this form, right? X plus yz form, x plus yz. It is of this form. Now I have written according to the distributive law. I have expanded this. Now observe this carefully. You have x and x bar in addition term. So x plus x bar, you know, according to the law of complementarity, it is 1. So y plus 1. Then y plus y bar is again 1. Then according to the property of 1, y plus 1 is 1 dot x plus 1 is also 1, which is equal to 1. So what did we try to prove? P plus p bar is equal to 1. But we cannot stop with this. We should also prove the next law, which says x plus x bar is equal to 0, right? So we will give that proof also. Now let us assume p is x plus y. Then what is p bar? That is, what is complement of x plus y? X bar dot y bar. This is what De Morgan's law states. Now we have to prove that p dot p bar is equal to 0. So what is p? X plus y. What is p bar? X bar y bar. Now you have to multiply this and prove that it is equal to 0. Okay. Now you can cross multiply x bar y bar into x. X bar y bar into x, right? Plus x bar y bar into y. Now observe this carefully. You have x into x bar. What is x into x bar? It is 0. So y bar dot 0. Here you have y into y bar, which is 0. So x bar dot 0. And you know, multiply any term with 0. Logical multiplication also gives 0. Hence, you get the answer 0, which is the proof of x dot x bar is 0. Right? So, you give the proof of the first De Morgan's law. The second law is a dual of the first one. So, obviously, this is also proved. So, you need to prove only any one theorem. Second one is automatically proved. You have to learn the proof of the basic three laws, which is the distributive law, third distributive law, absorption law. After that, learn the De Morgan's theorem and learn the proof of the first theorem. That is enough. Okay. Now we'll see how to find the complement of a given expression. Finding the complement is a important exercise, right? Find the complement. Find the complement of a given expression. Finding the complement is actually derived from De Morgan's law. X plus y whole bar is equal to x bar dot y bar. If you observe this carefully, there is a rule called break the line, change the sign. So wherever you have an operator, break the line there, right? And change the sign. Wherever you break the line, this plus should be changed to dot. If there is a dot, it should be changed to plus. That is called the complementarity operation. So to find the complement of a given expression, say for example, I have an expression called AB plus C bar D bar. Find the complement of AB plus C bar D bar. How to find the complement? What is complement? The complement of the full expression. Now break the line here because there is a main symbol here, the plus symbol. Break the line here and split it into two. So AB bar in one side, C bar D bar in the other side, and wherever you break the line, you have to change this sign. Now don't stop with this. Again you have a combined term here. So break the line here also. A bar, B bar, and wherever you break, you have to change the sign. Here there is supposed to be a dot. So change it to plus. And break the line here. It was supposed to be a dot here. So C bar whole bar plus D bar whole bar. Now complement of complement is what? The same number, right? So this is retained as such. Dot C double bar is C, D double bar is D. So this is how you find the complement of a given expression. So any expression is given, you just have to follow the rule, break the line, change the sign. Okay, so let us apply this. X plus y plus x bar y. This is a given expression. Find the complement of this expression. So let us find the complement. You have two plus symbols. So break the line in two places. X will become x bar. So here we have broken the line. So plus will become dot. Y will become y bar. This plus will become a dot. Retain the bar for this expression. X bar y whole bar. Right? So here there is nothing to reduce. So retain as such. Here I am going to further break down the line. So x bar whole bar. This dot is changed to plus y bar. Okay. X complement of complement. See, this symbol is also complement. This symbol is also complement. Complement of complement is the same element. Plus y bar. Dot, this is the same. X bar, y bar. No change in this. So this is the complement of the given expression. Now, when you start doing it, you have to follow this breaking the line, changing the sign. But once you practice, it is very easy. You can directly write it in a single step. I'll show you how to do that. It is given x plus y plus x bar y. So without drawing the line on top, I will simply tell you how to find the complement. X will become x bar, plus will become dot, y will become y bar, plus will become dot. Now here, consider this as a separate expression, x bar y. X bar will become x because x complement of complement. Dot will become plus, y will become y bar. So in the very next step, you can easily find the complement without applying break the line change. Without doing it step by step, you can finish it in a single step. Okay. So A, B, C bar plus B bar C. Suppose this is an expression, I have to find the complement. I will directly do it without breaking it step by step. Okay. A will become A bar plus B will become B bar. This dot will become plus. C bar will become C. So first term is over. Dot plus will become dot. Right? Now what about this B bar C? B bar B complement of complement will become B. This dot will become plus. C will become C complement. So either you can put it this way or you can put it like this. So answer is A bar plus B bar plus C into B plus C bar. This is the complement of this expression. Hope you all understood. In part 3, you will learn about the other logic gates called NOR, NAND, XOR and XNOR. You will also learn how to draw the logic circuit for a given expression. Thank you.